Hi there, this is Smart Haddad here again. So in this lecture, I have to explain to you why it's important to have routing in a network and our network. And when I say routing, that means we need to have a router because the router can do the routing. So let's imagine that we have this network. We have two switches connected to each other, and each of the switches, they have over here a network. That is the LAN, all right? So now, if we think of it, like in case we have a computers here, this is computer A, and this is computer B. Alright, so in case they want to reach to each other, then it's no problem. He send his traffic to this switch over here, and the switch open his MAC address table, as we have already learned. He has the port and he has the MAC address, and then he can send it to here, and it comes to B. Same do if you want to send from B to A. Also, this switch open his MAC address table. He has the port and the MAC address, and this is, he send it like this, and it reaches to the A. So in this case, we shouldn't really care too much about the routing, alright, because we have only one computer over there. But what if we do have, for example, 500 computers here, and here also 500. So that means that those switches, they need to have 500 entries inside of them to be able to make the resolving from the port to the MAC address. What if we have, for example, the internet? You have to think of it like all the internet is now connected via switching layer 2, because on layer 2 works the MAC address. So then in this case, the switches, they should have in their MAC address table the MAC addresses of all the devices which are on the internet, which is impossible because the switch is not having the capability to do that. Also, the switch is not having the capability to do that, or any other switches as well. So, and that's one of the things that you don't have enough resources on the switch to be able to handle all the MAC addresses, to be able to see all the MAC addresses of all the devices in the world. So this is one of the problem that in case you only have switching, then you may encounter. Let me clear it here so I can just put the information. So we can put here the MAC address table. So the MAC address table is not enough for that. All right. So that's one problem. Problem number two, let's imagine again that we have this network, and also we can think that we are connected to the internet, and in case one of the devices over here make a broadcast. The broadcast can happen, right? So we have seen that the ARP request works on the broadcast. So once the broadcast is coming to the switch, then the switch will send it to here, because it will be flooded to all its port, and come here, and this will receive the broadcast, and then it has to flood it to all its ports which are connected. So let's imagine that this switch have many ports connected to many switches, and it will go and go and go and go and go the broadcast without stopping. So when we have a broadcast, then in this case, remember, when it is a broadcast, then we have the network is down. So that's also another problem, that in case we only have switches, that we have problem when a broadcast happen, and the broadcast will happen in the network. So that means all the networks, if you have the internet all connected to the switching, then all the network will be down. And that's also something we can't have it, because in case this happens, then we don't have internet connected anymore. And that's something we would say that we can't really have only switches in case we want to have the internet, or in case we have a big network. So that's another problem that can happen, that the switch cannot stop the broadcast. We remember that the switch cannot stop the broadcast, and in case a broadcast will happen, then all the network will be down. So that's another problem, that in case we don't have router, because the router, we know that he can eliminate the broadcast, he can stop it, and will not forward it to the other ports. Then in case we don't have router, then this will happen. The other problem that may encounter is that, let's imagine that the switch can handle a lot of MAC addresses. Let's just imagine that. So then let's forget about the broadcast problem now. Let's imagine that he can handle all the MAC addresses. And this switch is connected to, for example, they are connected to the internet, to all switches. We don't have routers. So every switch has in his MAC address table all those MAC addresses. Let's imagine it's possible that he can handle it, but in fact, it's not possible, but just to imagine that it's possible. So in this case, this switch will have all the entries in his MAC address table, and this switch also will have all the entries in his MAC address table. So every time any PC want to send something to the internet, then this switch has to make a lookup to check all the MAC addresses, which are millions and billions and billions of devices which are on the internet. It has to check every time all those MAC addresses to reach to the destination that this PC wants to send it. Then that's also not possible, because in this case you will have a lot of delay on the internet, because the switch has to check every time for all the MAC addresses to reach to the MAC address that this PC over here wants to send it to the destination. So that's another also problem here, which is we can call it, for example, MAC address lookup. So it has to look for the MAC address to where it needs to send it, and this takes a lot of time to happen, which is impossible. So those are the three problems that we will have in case we only have switching in our network, which are the MAC address table, which becomes very big, and there is no resources for the switch to be able to handle all these entries in the MAC address table, the broadcast, and the MAC address lookup. So now, how can we solve this problem? To solve this problem, we require to have a router in between the switching networks. So we have here two networks, for example. Here is a network, and here is a network. Let's imagine that this network has an IP address here of 192.168.1.0/24, and this one is having 192.168.2.0/24. All right. So now what's gonna happen is that this router over here, because it's directly connected to the switch 2 and to switch 1, then he knows about those two networks. So those two networks, the router knows them, and he put them in something we call it the routing table. Routing table, you have to think of it as like the MAC address table on the switch, but this is based on the IP address. You can see we have IPs here and not MAC address. And he will say that, all right, 192.168.2.0 is connected to this port, and he will say 192.168.1.0 is connected to this port. All right. So now what's going to happen is that, let's imagine we have here 100 devices, and here we have 100 devices. So any traffic coming from here to the router going to 2.0, then it's not anymore looking to the MAC address table, but he will check to the IP. Okay, this is coming from 192.168.1.0. Where is it going? Going to 2.0. So we check in his routing table. Oh, I know about 2.0. It has to go from this interface, which is this one, and then he will forward it to here. And then the switch will resolve it on the MAC address, and he will send it to here, to the destination. So this is what the router can do. He do the routing, and it is based on layer 3. You can see based on the IP address. So what he will do is just have the IP address in his routing table, and as he knows about the destination, and then he can forward it to there. Now, when it is connected like this, because this network is directly connected, so you can see that it is directly connected to here, and it is directly connected to here. When it is connected, the router can resolve it directly. He can see it, it's connected to him. But some networks, they are not connected directly to the router. And in this case, we have to do some routing protocol. We have to use whether the static route or whether the dynamic routes. Okay, so something like this. If we have this router connected to another router, and this router over here has a switch, and this switch has a network here. So this is router 1, this is router 2, and this is the switch. Router 2 knows about this network because it's connected to him directly, but router 1 doesn't know about this network. Let's say that is network A. So in this case, we are required to do some configuration. So then at the end, router 1 knows also about this network. So in case he has a network connected to him, and this is a PC here, let's say here is B, and he wants to go to A, then this router 1 will know in his routing table how to reach to the network A. And here we have to do the configuration ourselves, whether we do it statically or we can do it using some dynamic routing protocol. And in this course, I'm going to speak about one dynamic protocol, which is OSPF. And in this section, I'm going to speak about the manual routing protocol, the static ones, that I'm going to show you how you can configure them. All right, so that's to explain to you why we need to have routing. So we understand now why we need to have routers, because if we don't have a router which works on layer 3, we cannot have routing. And if we don't have routing, we will fall onto the problems that I have showed you a few minutes ago in this lecture, and then we have a problem. So we require to have the router because the router works on layer 3 and the switch works on the layer 2, which is the MAC address. With the router, we can do routing for the packets. So this is what I wanted to show you in this lecture, why we need to have the router, and I have explained to you if we don't have the router, what problem can happen if we only have switches. So I hope that this lecture was informative for you, and the upcoming lecture I have to start doing the routing protocol, which is the static one, starting first with the static and the default route. So I hope that this lecture was informative for you, and I will see you in the upcoming lecture.